Hi guys, I'm John Kevin Muley from section CDE1A. I'm going to tutorial of limits of function and properties of function and limit of quotient. So I take the limit of function first. So I'm evaluating Italian Amora limits of given function. So this problem is necessary in of how answer to this example of limit function and how answer the given of to this example of limit function of given of value of x. So let's start with the problem. So the problem, we need to find the limit of function. Limits as x approaches 4, x minus 4 overall, x squared minus 7 times plus 12. Our first step, we will use an substitution. And I'm always looking the denominator. If the denominator make it equal to 0, so your functional numerator I change into 4 equal to 0, like this. X minus 4 or n, because numerator, all over 4 squared minus 7 times 4 plus 12, and equals x times 4 all over 16 minus 28 plus 12 equals x minus 4 all over 0. DNA or limits does not exist a 0 numerator. If we gonna use an additional one technique, he said the old new factoring. So this is the new technique. If we see nothing now, the function at an image, this, x, say some have a mile up, it's about, x. So we know all the denominator at all x minus 4. X minus 4, I've been added out, that didn't always make x, so factoring. So your factor, not 12, that will be give you negative 7, will be negative 4 and negative 3. Because negative 4 times negative 3 is 12, and then you add, and then you add, then up is negative 7. So you have x minus x 4 and 6 minus 3, and we know we can cancel this up, so we are this. Negative 4, negative 3. Para makancel na to makancel out is one as x approaches 4, 1 over x minus 3 minus 1 minus 4 equals 1 over 1 or equals 1. He took not in your first about the value of x1 of 4 minus 3 equals 1 over 1 or 1. Therefore the limits will exist. For use in international factoring technique to your problem, your limit will be excess. And that's it. Thank you guys. So now, we'll be dealing with the properties of limits. I wrote down 8 properties here on the side. The reason why I wrote them out on the side is because we're doing to be doing. Example, and when we'll be doing the example, I'll be referring to the properties to the list of properties. You can also find in your textbook. So let's go through them separately. So the first properties of limit as x approaches a, where k equals k is a constant, it just equal to k, the limit as x approaches of x is just equal to the limit as x approaches of a constant. The function you could take the constant out, take the limits of the function separately, and then just multiply the constant by the limits. The limit as x approaches of 2 function either added together, subtracted. You can split up the function, take the limits of the other function separately, and then plus or minus it depending on what you've doing. In the question, properties of 5, limit as x approaches a of 2 function multiplied together. Again, you could just split up the function, take their respective the limits individually, and then just multiply your result. The limit as x approaches of a of f of x divided g of x, take each limit separately, and then just divide your result. The limits as x approaches a of f of x is f of x is to the power of n. You would just take the limits of the function separately, and then whatever you result is take into the power of n. The limits of a approaches of a, of the square root of x function to the take of the limits of the function. For take the limits of the function first and then square root your result, and you'll get the same thing. That's it.